Welcome to today's episode of the Efficiency and Reliability Podcast. Today we will discuss a major case study from Integrated Global Services Incorporated, involving a biomass power station that successfully prevented boiler tube failure using HVTS. Over the years, the OEM, SFW and the IGS teams have collaborated closely to optimize turnaround schedules and scopes to maximize boiler performance and reliability. Follow-on projects included refurbishments, superheater bend protection, and expansion into new high-wear areas, ensuring long-term reliability of the fleet. A 460 megawatt electric supercritical CFB power station in Europe, burning 100% high-ash Silesian coal, faced accelerated metal loss from its first year of operation. Although designed to deliver reliable electricity at scale with enhanced environmental performance, the plant experienced severe erosion and corrosion on its boiler water walls, which led to quarterly outages for inspection and emergency repairs. Conventional solutions repeatedly failed. Iron-based thermal spray required hundreds of repairs every turnaround. Weld overlay caused tube distortion. Replacement was costly and time-intensive. Competitor coatings lasted less than 3 months. The plant needed a solution that would reduce outage frequency, eliminate tube leaks, and support long uninterrupted operating runs. In 2018, IGS and Sumitomo SHIFW partnered with the plant to trial a 10 square meter HVTS cladding patch in a high wear zone. After 6 months, the IGS patch remained fully intact with zero metal loss, while competitor solutions in adjacent areas had already failed. Based on this success, the operator and OEM engaged IGS to systematically replace failing claddings with HVTS, a solution proven to prevent recurring tube leaks without wall distortion, hot work, or extended outage time. Between 2018 and 2025, IGS carried out 13 mobilizations, gradually expanding cladding to all critical boiler zones. The operational impact was significant. Outages were reduced from quarterly to once per year, aligning inspections with planned shutdowns. There were zero tube leaks in cladded areas from 2019 onward. Major scopes were completed in as little as 9 to 12 days, preventing any extension of the critical outage path. In 2025 alone, more than 1,000 hours of downtime were avoided, preventing costly replacement of furnace walls and superheater bends. More than 2,100 square meters have been cladded since 2018, with no tube failures recorded in protected zones for 6 consecutive years. Quarterly interventions were eliminated and replaced with predictable annual inspections, and all work was completed with zero safety incidents, supported by a shared safety-first model between IGS and the OEM. Looking at the progression over the years, the 2018 test area showed no metal loss after 6 months, while other vendor coatings failed. In 2019, 690 square meters of failed cladding were replaced and inspected with zero defects. In 2020, all zones were inspected and found fully intact with no repairs needed. In 2021, 181 square meters and several spot refurbishments were completed in a 9-day turnaround, replacing the final vendor coating. In 2022, 26.6 square meters of thin areas were refurbished and protection was verified. In 2023, 264 square meters of cladding were added to the front wall with zero safety incidents. In 2024, 206 square meters were addressed with minimal degradation, requiring only localized refurbishment. In 2025, 940 square meters were applied across furnace walls and superheater bends, avoiding a full replacement and securing long-term continuity. As IGS Operations Europe's Andrzej Jasek noted, the goal was not only to stop tube leaks, but to give the operator and OEM the confidence to run a highly demanding boiler year after year. By reducing outages from quarterly to annual, the plant achieved the operational certainty it needed. That's it for today's episode. Next week we will have a new case study to discuss.